Before I start, I would like to publicly thank Blue Marble and Miles Davis for both mirroring and recommending my channel, and also to welcome my new subscribers who came over from these channels, and to thank everybody that has subscribed to my channel. So I left a comment on Ranty's video telling him about my last video. And Ranty replied with, "Seen the shit analysis. Shame you can't understand the simple stuff. Try harder next time." Now, on one hand, that was a little odd because I just pointed out a whole lot of looming going on in this photo. But Ranty does have a point when I raised the right photo later in my video to align the top of the can. And the reason I did this is I thought I had evidence that he had cropped the photographs. But after looking at more of his video evidence on this topic, I can say that I made a mistake and he did not do this. So the reason I thought he might have been cropping his photograph is because of what was going on in this area. If you look at the ruler on both sides, we see that there is no change between the number 4 and the number 5. But why is this label over here stretched higher than it is on the right? And there was actually a few comments about this too. But this comment by Crozy on Blue Marble's channel gives us a clue. And he says, "I did point out to Ranty about the looming dot. He said the image on the left that is taken as a reference was during the mixture still not settled down." So if the mixture hadn't settled down, that could explain why we see a refraction difference in this area. And when I play Ranty's video, you're going to see these objects wobble up and down. Of course, this brings up another question. Why didn't Ranty use plain water as a reference? This way he would be comparing a density gradient to plain water with no density gradient. And you have to wonder, did he document this but didn't use it because it didn't fit his narrative? Now here's another short 54-second video by Ranty that was released later on the same day. And in the description, he said, "Quick time lapse showing the effects of sinking. More sugar water was added to the tank, creating a density gradient." So Ranty starts with a sugar water solution on the left, and then he adds more sugar water to the right, and he says this creates a density gradient. Of course, the funny thing is we see no obvious refraction in the right photo. The 4, 5, and 6 in my ruler align with the 4, 5, and 6 in Ranty's ruler. And I really don't even need to add a ruler to the left photograph because the refraction is plain as day. So we can see a definite case of looming because this section on the can on the right is raised higher over here on the left. And we also have an example of towering, which of course is related to looming, but the difference being is that the object is stretched higher. And in the real world, it is not uncommon to see both of these phenomena at the same time. So we start with a clear case of looming and towering, and Ranty just dumped in another load of sugar water, which of course stirred everything up and destroyed the existing density gradient. Now look at all the wobbling up and down due to the variations in refraction. Now what is happening is that this is actually settling down into a constant gradient from top to bottom. But of course with time, this will reform into a brand new density gradient. Now I don't have a fish tank, but I'm going to demonstrate this with a brown sugar solution in a glass. So you can clearly see the density gradient, but when I pour in some water, it mixes everything up, which of course destroyed that density gradient. So was the apparent sinking caused by a density gradient? Of course not. Ranty actually destroyed that gradient by adding more sugar water. Now 2 days later, Ranty has a live stream and a guest is pointing out the obvious. And that is in regard to these 4 photographs where you see decreasing refraction from the top to the bottom.
You're saying the cans disappear behind the plant pot?
Yes, well, that's what has happened. I'm not saying
But
it.
I'm saying it might have happened the other way. Maybe it was always behind it, and your sugar solutions made it stretch up above it, maybe.
This was the strongest solution at the bottom. So the more solution that I kept putting in, I kept putting more sugar solution in. Yeah.
You're saying it started by looking all stretched, and then the more solution made it go back to normal behind the plant pot.
No, the first image that I took up the top, right, this very first image up here, was taken with...
That looked well stretched, though. Look at that tape.
Yeah, as I say, when I first did this on day 2 or what have you, I think this was after it had settled down overnight. So all night long it had been settling, right? And there was, I believe, 3.5 kilograms of sugar in the tank on this particular image.
Instead of me pulling up discrepancies, your conclusion is sugar solution makes things...
No, sugar solution increased the density inside the tank, and the increased density in the tank created the visual thing that you're seeing here.
Unbelievable. So Ranty not only admits that the solution had set overnight in the photo on the left, but he also admits that there's obvious stretching or refraction. But he's also changed the story a bit, because now he is claiming that it is increased density that is causing the sinking. Well, unfortunately, that guest left shortly thereafter, because what he should have done is said the obvious. Ranty, that is not sinking. It is looming that is happening in the first photograph. Now, this is something else to consider. This was a comment that Walter Bislin made on Blue Marble's mirror of my video. And he says at some point the water is saturated at the bottom so much that the gradient gets lesser when we add more sugar. The density may still increase, but the gradient decreases. So let's start with a sugar solution where we have a density gradient from top to bottom. So you add more sugar, let it set overnight, and it's going to get to a point where you're going to have a saturation on the bottom with little or no gradient. And of course the saturated area will get larger when you keep adding more sugar. And as Walter correctly says, only the gradient causes the bending of light, not the magnitude of the density.
And your sugar solutions made it stretch up above it, maybe.
This was the strongest solution at the bottom. So the more solution that I kept putting in, I kept putting more sugar solution in. Yeah.
So is this really a controlled scientific experiment or confirmation bias? Well, take a listen to this live stream with Ranty and another flat earther.
Well, this is supposed to say primer, and you see how low down the wording is in relation to the top of this obstruction, this pot that's in the foreground. And then look at the start of the video. Look where it started off. Look there. It's way... You can read it all. You can read the words primer. And then when you get to the last image, like down here, you can only read prim. You can't see the ER. That's completely sunken behind the pot.
Well, that's the part that got me so pumped when you put out your video earlier today, and I watched it. That's the most obvious change that you can see, is that word primer going down. That is something being obstructed from the bottom up, period.
Yep, absolutely.
That's not scrunching. You can call it whatever you want, but that image is sinking behind that pot in the foreground.
Yep.
Sorry, but only in a flat earth echo chamber could you ignore the obvious. I really don't even need to add these rulers to understand that on the photo on the right we see little or no refraction, and we see obvious refraction on the photo on the left. So how could anybody make the claim that this is sinking when what we really have is a case of looming on the left photograph? So the reality is that even though Ranty taped the ruler in his experiment, he could not identify examples of refraction. Therefore, he didn't understand that when he poured in more sugar solution, he actually created a temporary solution with no gradient. He also assumed that adding more sugar was the equivalent of making a density gradient. So Ranty assumed that he had documented sinking, and in one video he said it was caused by a density gradient, and in another video by increased density. Which of course brings us back to the question, why didn't Ranty use plain water as a reference, which would have correctly shown looming? So my conclusion is that we have another case of confirmation bias. It's shocking.